Okay, so terminology, A is the first term still, and what we call the ratio, how many times we times something to turn it into the other one. So Sn, this is given in the formula booklet as this, but this is what we're going to prove. And you need to know what S to infinity is. Now, for S to infinity, you have to have a ratio, which is, you say mod R is less than 1. So it means whatever the answer is, positive or negative, it's just going to be less than 1 or bigger than minus 1. Okay, so for instance, if you have a number, right, if that's 2, and then I was timesing that by like 1.1, so its ratio was, its common R was 1, and the next answer is 2.2, and if I just say answer times by 1.1, that answer is just getting bigger every time. So bigger, bigger, bigger. So it's just getting bigger and bigger and bigger. So if I added up all the numbers to infinity, it'll obviously get to infinity. However, if I did 2 times by, say, 0.3, which was then 0.6, I then times that answer by, was it 0.3 I just did or something, and then I can keep on timesing by that number, then eventually I'm getting such a small number that if I keep on pressing equals, it will probably go to 0. But maybe I'll have to press it an awful lot of times. But so far, in standard form, we're talking about that number to the minus 20 is more or less there. I would have thought that if I was sad enough to keep on pressing equals for a long time, that it would go to 0. Okay, so because we're getting such a small number, eventually my number 2 will eventually become 0. So then when you add up all those numbers, it will just be a number. So that's what it means when it says S of infinity. Okay, it means that it's going to eventually end up being 0. Okay, now if your ratio was, say, a half, say your ratio is a half there, to the power of n, if that becomes infinity, we say that any number that is less than 1 to the power of infinity will eventually become 0. So 1 take away 0 is 1, and then a times 1 is just a. So it becomes a over 1 minus r, but that's given. This is both given, these things here, but it's useful to know that bit for when you're doing things. Okay, so proof is as follows. Sn equals, so it's the first term, and then the next term, so we're adding them because the S means sum, and then we'd say it's a plus r times by the common ratio, and then we're going to times by the ratio again to that term, so it's be a times r, and then times r again, so we can say that's ar squared. Okay, now if that's the first term, that's the second term, that's the third term, what do you notice about the number term and its power?
1 less.
It's 1 less. So for the nth term, this would be ar to the n minus 1. Okay, so I'm going to get this sum again. I'm not going to reverse it like I did with APs. APs I'll do the reverse bit. But this bit, I'm going to use that idea from the video. I'm going to write exactly the same thing, but I'm just going to push it along a little bit, and I'm going to times it by r. Okay, so that a times by r becomes ar, but I'm going to write that underneath ar. That ar times that by r becomes plus ar squared, and plus da 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 da. So we're going to get ar to the n minus 1. Okay, but when I times that by r, I just get a to the rn, because when I times that by r to the 1, if I write that just like aside by here, a to the r to the n minus 1 times by r, that's the power of 1, that minus 1 will plus 1, effectively cancelling out that and that. How do you feel with that idea? A bit?
Maybe again.
Okay, so happy with the first bit? This a times by r becomes ar, so it's sort of like just going across diagonally.
Right, yeah, I see.
So I'm doing effectively a to the r to the n minus 1, so that last term there, and then I'm times that by r, effectively r to the power of 1, and that means that I add the power, so I get n minus 1 plus 1 cancels to being a to the rn. Okay? Now what I do is I do that smart way of taking away. Okay, so I'm going to take away this one, take away this one, so it's going to give me Sn minus Rsn. Okay? A take away, well, there's nothing there, so that remains there. AR take away AR, cancels. AR squared take away AR squared, cancels. And it's going to cancel the whole way along. That's going to cancel as well, but then I've got nothing here, but I want to take away AR to the n, so I need to take away AR to the n. Okay? Final bit, do you see anything that's the same on both sides here?
Yes,
So let's pull that out as a factor, so that'd be 1 minus r. And then anything that's a factor here? So that'd be 1 minus r to the n. And then, because that's times, and take it over to the other side, it becomes a divide. And that's your proof.